All right, welcome everybody. Today we are going to kind of review synthesis reactions and predicting products. This is a pre-lab. This is on page 9 of your notes packet. This little quick review is going to help you with your lab that you'll be watching today and completing. The lab is the activity series of metals, also on Google Classroom, and you'll complete the separate handout on the activity series of metals after you watch the videos. So let's go ahead and get started. First of all, I want to review synthesis reactions. So remember that in a synthesis reaction, you're creating something new. So essentially, from two reactants, you're forming one product. So your key identifiers, if you find or see one product in a chemical reaction, then that's how you know it is a synthesis reaction. So over here you've got a reactant forming one product. This is your key that this is a synthesis reaction. If I've got a metal and a non-metal, I'm going to use the crisscross method to figure out what the formula would be, and then I'm going to balance that equation. So let's go ahead and look at Al plus O2. So when Al and O2 combine, they're going to form one product. Now, aluminum is a metal, oxygen is a non-metal. So I know that this is an ionic compound, so I need to know the crisscross, I need to know the charges so that I can use the crisscross method. So aluminum and oxygen. So aluminum is in group 13, which means it's got a positive 3 charge. Oxygen's in group 16, which means it's got a negative 2 charge. And when I cross the charges, the 2 will come down here, and the 3 comes down here, and I end up with Al2O3. So I end up with aluminum oxide. So now I need to balance the equation. Well, let's see here. Here I've got one aluminum. Here I've got two aluminum. So I know something is not right here. I've got 2 oxygens and 3 oxygens on this side. So you can use the box method if you would like. We can go ahead and do that. Let me do this in a different color so we don't get confused. So there's my arrow. I've got aluminum on this side. I'm going to put a box around it. I've got 2 oxygens bonded together. I'm going to put a box around it. On this side, I've got Al. I've got 2 aluminums and 1, 2, 3 oxygens. Okay, so we said that there was 1 aluminum here, 2 aluminums here. So to try to balance that out, I'm going to add an additional aluminum here. So now I've got 2 aluminums on the left, 2 aluminums on the right. Oxygens, I've got 2 oxygens here and 3 oxygens here. So what I'm going to do is I'm going to add oxygens to the lower side. So now I've got 4 oxygens on the left and 3 oxygens on the right. So I want to balance that out, but I can't just add 1 oxygen. I've got to add everything that's bonded together in that compound, which means 3 oxygens and 2 more aluminums. So now I've got 6 oxygens on the right, 4 oxygens on the left. So to balance that out, I'm simply just going to add another pair of oxygens. And now I've got 2, 4, 6 oxygens here, 3, 6 oxygens here. But when I added oxygens over here, I added aluminum. So I've got 1, 2, 3, 4 aluminums and 2 aluminums on the left. So the easy thing to do is to simply add another 2 aluminums. I'm running out of space here, so I'll write it to the left. So I've got 1, 2, 3, 4 aluminums, which means my coefficient becomes a 4. I've got 1, 2, 3 boxes with oxygen, so my coefficient becomes 3. And then I've got 1, 2 boxes of aluminum oxide, so my coefficient becomes 2. So my coefficients are 4, 3, 2. So So now I'd like you to take a moment to try the one on the right. I want you to try this one, potassium plus chlorine. See if you can identify what the product would be. I'll give you a few minutes to work on that. Go ahead and pause the video, and when you're ready, you can unpause the video, and I'll share the answers with you. All right, so let's look at potassium and chlorine. So potassium is a metal. Chlorine is a non-metal, so this is an ionic bond that's going to form. It's going to form one product. So potassium is in group 1, it's got a +1 charge. Chlorine is in group 17, so it's got a -1 charge. So when I crisscross them, the 1 comes down here, the 1 comes down here, and I simply get K1Cl1, which is just KCl. All right, so let's see if this is balanced. I've got 1 potassium here, 1 potassium here, 1 chlorine here, 1 chlorine here. So this one is already already balanced. Therefore, you don't need to do anything. The coefficients are 1, 1, and 1. Okay. So let's look at a single replacement reaction. A single replacement reaction. So remember, in a single replacement reaction, we've got an element and a compound on both sides of the equation, on both sides of my equal sign. So here I've got this is a reactant, product. Specifically, this is an element, this is a compound, this is a compound, this is an element. So I've got a compound and an element on both sides. Okay, the metal will replace or kick out another metal only if it's higher on the activity series list. Okay, so just to kind of give you a refresher, okay, so the activity series list on the reference chart shows the general reactivity of these metals. So the higher up the metals are, the more reactive they are. Okay, so which metal is the most active? So the metal that's the most active would be lithium. Which one is the least active reactive metal? All right. So let's look at our first single replacement reaction. So I've got K plus CuCl2. So potassium plus copper chloride. All right. So potassium is a metal. Copper is a metal. Chlorine is a non-metal. Okay, so metals can only replace other metals. So potassium can only replace copper. So let's take a look to see in our activity series. We want to see if potassium is higher up on the list than copper. So I know that this reaction will take place. So that means that potassium will replace copper. Okay, because it's higher up on the list. So because I've got an ionic compound formed here, then I need to figure out what the new formula is going to look like using the crisscross method. So one thing that I do know is that potassium is going to kick out, it's going to replace copper. So I know that copper is going to be by itself. Okay, so I can go ahead and write copper in there. I need to now figure out what compound will form between potassium and chlorine. So potassium has a +1 charge, Chlorine has a -1 charge. So when I cross the charges, the 1 comes down here, this 1 comes down here, and it's K1Cl1, which is just KCl. Okay? So there's my single replacement reaction. I've got an element, a compound, forming a compound and an element. So I've got an element and a compound on both sides. Now I'd like you to try B on your own. Try B on your own. Pause the video, take some time to see if it'll react, write the reaction, and unpause the video to check your answers. Okay, so first of all, we're going to identify what's a metal, what's a nonmetal. So Ni is a metal. Hydrogen is technically a nonmetal, but because it acts like a metal, we're going to say it's a metal, and chlorine is a nonmetal. So I'm comparing, I need to look at nickel and hydrogen. So I'm going to refer back to my list. So that means that this reaction is going to take place. All right, so nickel is going to replace hydrogen. This will take place, which means that hydrogen is going to get kicked out. So I know that on this end, my element is going to be hydrogen. Now, one other thing that I want to mention is that you have to remember your diatomic elements. So these exist in pairs, so that means that they need a subscript of 2 when they are not part of a compound. So when they are by themselves, they need a subscript of 2. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. Here is hydrogen. Hydrogen is by itself, so I need to add a subscript of 2 right away to complete that reaction. Okay, so now I need to figure out what's going to form between nickel and chlorine. Alright, so nickel is a transition metal. I'm going to go ahead and give you the charge for nickel. We're going to say it's a +2. And chlorine is in group 17. It's got a -1 charge. So when I cross those charges, the 1 comes down here for nickel and the 2 comes down here for chlorine. So I get Ni1Cl2 or simply NiCl2. And there's my equation. So I had an element, a compound, and an element. Let's try the last one here. Silver plus potassium nitrate. So silver is my metal, potassium is a metal, nitrate is a polyatomic ion, so it's a nonmetal. So I'm really looking at silver and potassium. So in order for this reaction to take place, silver has to be higher up on the list than potassium. So let's take a look. It means that this reaction will not take place. This will not occur because silver is lower than potassium. So therefore, no reaction will take place. Alright, so let's look at some practice questions here. Compare reactions A and B. Which reaction do you think will occur faster or slower? So take a minute to look at reactions A, look at reaction B. So in reaction A, I've got potassium and chlorine. So, and in B, I've got nickel and hydrogen. So reaction A will occur faster because potassium is way higher up than copper. All right. And number 2, which element will react most like potassium reaction in cesium in reaction A, cesium or scandium? Periodic table. Think about which elements are in the same group as potassium. So potassium is in group 1. So which other element is in group 1? Well, it would be cesium. Therefore, it's going to have the same reactivity based off of the same valence electrons as potassium. All right. The activity series list was on this part of your reference chart, so I recommend that you use the reference chart. You will need it for the lab. Okay, so remember, as metals go up, as they increase this list, they become more active. So lithium is at the top of the list, which means it can replace everything that is below it. So a metal can only replace another metal if it is above it on the list. So for example, zinc is right here. Zinc can replace anything that is below it on this list, but it cannot replace anything that is above it on this list. Look at the list. The metal that's at the highest point here is, well, I'm going to look at the one that's at the bottom of the list, and it is gold. Gold is my. So on my list, I'm going to find potassium. Here's potassium way up at the top. Potassium's way up here, and copper is way down here. So because potassium is higher up on the list, it can replace copper. Refer back to my list. Here is nickel. Here is hydrogen. So nickel is higher up on the list, so that means that it can and will replace. Okay, here is silver. Potassium's way up here. So silver is actually below potassium, so it will not replace potassium. So let's take a look at this list. I have potassium and copper, and then nickel and hydrogen. So let me put some marks on here. So I've got potassium and copper, and then I had nickel and hydrogen. All right, so look at the difference between nickel and hydrogen compared to the difference between potassium and copper. So those elements that have the greatest distance between each other have the highest reactivity. They're going to occur the fastest. So potassium's way up here, copper's way down here, which means these are going to react very fast compared to nickel and hydrogen, which aren't very far apart. So this reaction is going to occur. It's just not going to happen as quickly. Okay, so when I look over here, I see neither one of those on this list. Okay, so think about this for a second. In our activity series list, I see aluminum. Here's zinc. Aluminum is higher up on the list than zinc, so this reacts. So find sodium on the list. Here's sodium. And hydrogen is down here. So sodium is higher up on the list than hydrogen. Let's go ahead and take a look at the practice reading chemical equations on this side. I want you to, it's saying to predict what happens when aluminum metal is added to a solution of zinc chloride. So aluminum metal is added to a solution of zinc chloride. All right. So aluminum metal. So aluminum is Al. Zinc chloride. So zinc is a metal. Chloride is referring to chlorine, which is a nonmetal. So let's figure out what the formula for zinc chloride would be. So zinc is Zn, chloride is Cl. So when you take a look at your periodic table, and find zinc, you'll notice that it's a transition metal. So I'm going to give you the charge of zinc. Zinc is going to have a +2 charge. Chlorine, like we know, is a -1 charge. So the formula for zinc chloride, when I crisscross the charges, would be Zn1Cl2, zinc chloride. Alright, so let's put this formula together. So I've got aluminum metal is reacting with, so plus zinc chloride, so ZnCl2. I want to figure out what will be formed here. So my metals are aluminum and zinc. So let's see, does aluminum replace zinc? Let's take a look at what will take place. Okay, so that means zinc is going to get kicked out. So zinc will form all by itself over here. So now I need to figure out what formula is going to form between aluminum and chlorine. So aluminum is +3, chlorine is -1. So when I cross the charges, I get Al1Cl3. So when aluminum and zinc chloride react with each other, they form aluminum chloride and zinc. Now I want you to try reaction 2 on your own. See if you can complete reaction 2 using the hints and the notes that we did in example number 1. Go ahead and pause the video, and you're ready to see the answer. Press play. So number 2 says, write a reaction that shows what happens when sodium metal is added to water. So sodium metal, sodium is Na, and water we know is H2O. So what happens when sodium and water react? So I'm going to write sodium metal plus water. Let's see what happens. So identify your metal. Sodium is a metal. In H2O, I don't have a metal, but based off my activity series list, hydrogen acts like a metal. So if anything, sodium will replace hydrogen. Let's take a look and see if it does. This reaction will take place. Okay, so that means that hydrogen is going to get kicked out, and it's going to be all by itself. Remember that hydrogen is one of those diatomic elements, so I need to add a subscript of 2 when it's by itself. Okay, so sodium and oxygen. I need to figure out what will form between sodium and oxygen. So sodium is a +1 charge. Oxygen is a -2 charge. When I cross the charges, I get Na2O plus H2. So here's what's formed when sodium and water react together. So we've just completed the pre-lab notes for on page 9 for the activity series of metals. Now I'd like you to watch the video demonstration of the activity series of metals on Google Classroom and complete the lab, which is a separate handout.